Okay, today's lesson, this is 4.3, day 2. You can find this on your textbook page if you want to add that on. Page 157. Parallel lines and their equations. How to identify and write equations of parallel lines. I'm in page 31 of your packet. And I know that the print is not as good, so hopefully you can read it on this screen. The packets didn't print very well. The lines shown at the right are parallel. Lines in the coordinate plane that have the same slope. So our coefficient of x here, the same slope up to and over 3, but have different y-intercepts are going to be parallel. So my slope on both of those lines is 2/3, as you can see here. They have different y-intercepts. One of them's 2, one of them's 5. You can use the fact that parallel lines have the same slope but different y-intercepts to write equations for parallel lines. Parallel lines always have the same slope. If the equations are written in slope-intercept form, it is easy to know if the equations are parallel even without seeing the graph because they have the same slope. So number 1 here says, rewrite each pair of equations in slope-intercept form. That means y equals mx plus b form. Then decide whether the equations are parallel or not. And in this first example here, I believe this little x is missing on your paper. 3y equals 15x minus 21. So please put that in. This is in y equals mx plus b form. That equation is fine. This is not y equals. So we're going to divide by 3. Divide by 3 and divide by 3. Then we get y equals 5x minus 7. So the slopes, the coefficient of x, they're both 5 over 1. So yes, these are parallel. They have the same slope. Different y-intercepts, but same slope. Number 3 here. I'm going to go across to number 3. Y equals, oh, that's not y equals, so we're going to subtract 2 and put it into the function form or the slope-intercept form. Y equals 3x minus 2. 2y equals 2x minus 2, 12x minus 2. Well, we got to divide everything by 2, each term. Don't forget each term. Dividing by 2, we get y equals 6x. Negative 2 over 2 is minus 1. So here my slope is up 6 and over 1. Here my slope is up 3 and over 1. They are not parallel, not the same slope. So not parallel. Example number 2 here. 6x plus 9y equals 3. Well, we've got to subtract 6x first to get it into slope-intercept form. Then we get 9y equals negative 6x plus 3. Dividing by 9 each term, I get y equals negative 6/9, which does simplify to negative 2/3 x, and 3/9 simplifies to 1/3. So that's the first part of the equation. Y equals negative 1/2 x plus 4. Well, this is a slope of negative 1, down 1, and right 2. This is a slope of down 2 and right 3. So my slopes here are not the same. These are not parallels. I'm going to write not there. Number 4, last one. 8y, well, dividing by 8, each term by 8. I get y equals negative 1/4 x when I simplify that, and minus 10/8. I'm going to leave it rational, minus 5/4. So y equals negative 1/4 x minus 5/4. Not in slope-intercept form, my second equation, 7 plus negative 4y equals x. Well, first thing I'm going to do is subtract 7 from both sides. And I get negative 4y equals x minus 7. Dividing by negative 4, negative 4, yep, negative 4. I get y equals, hey, negative 1/4 x plus 7/4, simplifying negative 7 over negative 4 to positive 7/4. I get negative 1/4 x in my second equation. Negative 1/4 is that coefficient of x, my slope. And in the first equation, negative 1/4. So yes, these are parallel. Same slope, parallel lines. On to page 32. Write an equation of a line given its y-intercept and the equation of another line parallel to it. So they're going to give me two parts. They're going to give me the y-intercept, the b, and an equation of another line parallel to it. Well, if it's parallel, I know I can pull the slope off of that. An equation of a line is 2y equals 6 minus 3x. Write the equation of a line parallel to this that has a y-intercept of 6. Well, first write the given equation in slope-intercept form. They divided by 2 everything. Then you get y equals 3 minus 3/2 x, or y equals negative 3/2 x plus 3. The given line has a slope of negative 3/2 and a y-intercept of 3. But they said the line parallel to it with the same slope and the y-intercept now of 6. So the equation would be, here's the answer, substituting in the slope, y equals negative 3/2 x plus 6. So substitute in both the slope and the y-intercept, and we have the right equation. And yes, those are parallel. Given an example of another equation for a line that is parallel to the two lines in example 9, give an example of another equation for a line that is parallel to the two lines in example 9. Well, another equation would be y equals negative 3/2 x minus 2, for instance. Same slope, different y-intercept. Okay, last couple questions here. So number 5, a line has an equation 3y plus 6 equals 10x. Write the equation of a line parallel to this given line that has a y-intercept of 2. Well, first thing I have to do is solve this in slope-intercept form, which means divide each term by 3. Y plus 2 equals 10/3 x. And I'm going to subtract 2. So my equation is y equals 10/3 x minus 2. So a line parallel to this would have to still be y equals 10/3 x and has a y-intercept of 2. Oh, okay, plus 2. So now it's a line parallel, and it has the different y-intercept of positive 2. So we're done with number 5. Number 7. It might be hard to read this, but this is a slope y-intercept of positive 2 here. The line has the equation 4y equals 3x minus 8. Write an equation of a line parallel to this. It has a y-intercept of positive 2. So 4y equals 3x minus 8. I'm going to divide by 4. And I get y equals 3/4 x minus 2. So a line parallel to that would also have to be y equals 3/4 x. And its y-intercept now is positive 2, so plus 2. I'm going to leave number 6 and number 8 for you to complete on your own, and that will be the first thing that we check in our notes together when we come to class. So that's it for today.